In 1.4, we're going to be rewriting equations and formulas. So an equation that has two or more variables is called a literal equation. And to rewrite a literal equation, we're going to solve for one variable in terms of the other variables. So we're going to start rewriting the equation for something a little more simple than what we're going to see later in the lesson. So we're going to have negative 3y equals 6 plus 2x. And in this case, you're going to see that we have variables on both sides of the equation. We have y and we have x. And in this case, we want to solve for y, which means we need to get y all alone on that side of the equation. And so we just have to start eliminating what's happening to the variable we want to isolate one step at a time. So I will divide by a negative 3 and divide here by a negative 3, and that gets me y by itself, so I end up with y equals 6 plus 2x over negative 3. Now, we're not done because now I can simplify this even further. And so when I take a look at what's happening here, this is going to become a negative 2/3 x because I can't simplify that anymore. And then here I can reduce to, or simplify to a negative 2. Now, why they flip-flop these, I don't really know. If they didn't, however, it would have ended up with negative 2 in the front, and I think they just like to have the variables be the first part of the equation. So I think that's why they flipped them. I'm not entirely sure. Looking at one more example of those, 5y minus x equals 10 plus x, and still in this case I want to solve for y. So I'm going to start eliminating what is happening to y here. Oh, I'm sorry. 5y minus x equals 10. That's the equation we're starting with. And so now we're going to get rid of the x on this side, which means that when we rewrite it, we will have 5y equals 10 plus x. And now that I am reducing or simplifying for y, I can divide each of the sides by 5. I've gotten y all by itself, and now I'm going to end up with y is equivalent to, we've got 2 here, because 10 divided by 5 is 2, and then really remember this is a 1x, so I end up with 1/5 x. If you wanted to rewrite that the other day, 1/5 x plus 2. And this remains a 1/5 because I can't simplify that. All right, looking at number 2, we're going to be rewriting a formula. So in this case, I have a formula for the surface area of a square pyramid, and that happens to be big S equals x squared plus 2x, and that's an L. We want to solve, in this case, the formula for the slant height, which is L. So we are going to be trying to isolate that L here. So once again, I have to get L all by itself, and I'm going to begin by taking the x squared away and do that to both sides. So now on the left side of the equation, I have x minus x squared, and I just am left with 2x with a slant height of L. Still trying to get L by itself. I'm just going to, I notice all these are being multiplied, so I'm going to divide by what I need to get rid of, which is 2x. And I'm going to divide by 2x on this side. And I end up with L being equivalent to S minus x squared over 2x. And I can't simplify those any more than what they already are. All right, number 3, we're going to be rewriting the temperature formula. So for Celsius to Fahrenheit, if you've ever traveled abroad and tried to cook something, you know, it's a little tricky when you have to try to convert temperatures. So here we've got Celsius is equivalent to 5/9 of whatever your Fahrenheit temperature is minus 32. So the question becomes, all right, well, what if I want to rewrite that formula so I have Fahrenheit? What would Fahrenheit be equivalent to? And so in this case, we want to isolate for F. So now it becomes a formula where F is equivalent to an equation. And so I need to start undoing all of this math. And to get rid of the 5/9 being multiplied by F, which is what I want to do first, of course I have to multiply by the reciprocal of 5/9 or 9/5 and multiply by 9/5 on this side as well. So now I've got 9/5 C is equivalent to F minus 32. Still trying to isolate F so I can rewrite this formula. So F is on the outside here. So I'm going to add 32 and then add 32. And I've got 9/5 C plus 32 equals Fahrenheit. So now I've got two equations, which no matter if I have the Celsius temperature or the Fahrenheit temperature, I now can set myself up for success to solve for each one. I can either plug in Fahrenheit or I can plug in Celsius. So we can use that in a real-life application, such as this next one we are going to look at, to decide which one of these has a greater temperature. So if I'm starting with my Fahrenheit equals 9/5 times Celsius plus 32, and let's say that I'm comparing the temperature of the sun, which is 11,000 degrees Fahrenheit, to the temperature of lightning, which is 30,000 degrees Fahrenheit. I want to see which one is actually hotter, the temperature of the sun, which is 11,000 Fahrenheit, or the temperature of lightning, which is 30,000 Celsius. So now that I have an equation that I can plug in for both, I should be able to solve for this problem. So I know my Celsius temperature of lightning is 30,000, and I want to find out the equivalent Fahrenheit temperature. So 9/5 times 30,000 plus 32, so that's what it says up here. I want to find out what the equivalent Fahrenheit would be. I'm going to multiply these together, and just for the sake of time, I will tell you that 9/5 times 30,000 is 54,000. And we add the 32 to that, and I end up with 54,032 degrees Fahrenheit. So I now know that a 30,000 degree Celsius temperature is much hotter than an 11,000 degree Fahrenheit temperature, which was the sun. And so lightning obviously is much hotter than the sun. All right, so one more temperature problem, and then we'll be done with this video. So which temperature is greater, 400 degrees Fahrenheit or 200 degrees Celsius? I'm going to use my Celsius equation again here, or that we solved for in step 3. 5/9 equals Fahrenheit minus 32. So I know my Fahrenheit temperature is 400, so C equals 5/9 times 400 minus 32. And once again, I need to multiply by the reciprocal. And I'm going to have 400, oh, whoops. Sorry about that. I am not going to multiply by the reciprocal. I am just going to solve using PEMDAS first. So let's rewrite that real quickly. C equals 5/9 times 400 minus 32. Okay, because I've already got C all alone, now I just need to solve through the equation. So 400 minus 32 is going to give us 368. And now I can just multiply that by 5/9. And once again, just for the sake of time, I will tell you that when we multiply 5 times 368 and then divide by 9, I am going to end up with 204.4. And that is going to be representing my degrees Celsius. So once again, if I had 400 degrees Fahrenheit, that is equivalent to 204.4 degrees Celsius, which when you look to see what you were comparing with up in the beginning, which was 200 Celsius, you can now see that 400 degrees Fahrenheit, which is equivalent to 204.4 degrees Celsius, is greater than the 200 degrees Celsius.